Hey everybody, Thomas here. Today I want to talk about a little topic that I've seen often in this group. It's about the cabling of flex strips. So often in the groups we can see connection schemes like you can see in the video. And today I want to show a very big problem on this connection schemes with the help of a thermal camera. And yeah, so let's get started. Often we see people connecting the flex strips like this. They have a very big power supply unit, 20 amps, 60 amps or whatever, and then they just connect the 5 volt and the ground to every strip, and they loop the data signal in orange here through the strips. So I've done the same setup here on my desktop or on my workbench. You can see I have a very big power supply here, and I have 2 strips connected directly to the 5 volt of this power supply unit, and they are looped through with the data. This is yellow cable here, and at the moment I have something like 20 degrees in my room, and when I film this, when I take a picture with the thermal camera, you can see the surface is roughly at 20 degrees on both strips. And the Arduino is really getting warm at 23 degrees or something. But one really big issue on this type of cabling is the short circuit current. If there is a short circuit somewhere here in this connection, the power supply unit will not detect a short circuit because the resistance in the small strips is so high that the power supply unit will not detect a short circuit, and then it will always continue to power the strips. So I have my multimeter here, and now I will measure the resistance over this 8 pixel strip. So I will measure from the V plus, so from 5 volts to the end of the strip, and you can see we have 0.2, 0.3 ohm here on this short length of cables and flex strip. The cable that I use is standard 0.75 square millimeter, so not the smallest one. And yeah, as I've seen, it worked before. And now I have a short cable here. It's roughly ½ meter, and I will connect this cable in a loop to create a short circuit at the end of this small flex strip. So I will just solder the cable here. Okay. Not the best soldering. 1 second. Now it's looking good. Okay, and what you will see now is when I switch on the power supply unit, the Arduino gets power, the flex strip gets power, this one will continue to work, and this one will get really hot. They are glued to a piece of wood, and I've seen this often, that people glue the strips to wood or behind the television to have something like an ambi light or something like this. And yeah, so let's do this. So you can see the strips are off. They are at room temperature, 18 degrees. And when I switch on the power supply unit, you can instantly see that the lower strip gets really hot. 150 degrees, 200 degrees, 250 degrees. And then the small cable is here disconnected because the temperature got so hot that the solder was melting. And you also can see that these cables are really glowing hot. They are something like 60 degrees. The full strip is really glowing hot on the thermal camera. You can see also the cable at the end of the loop is something like 50 degrees. And yeah, the power supply still continues to give energy, and it didn't switch off because the current was not high enough to trigger to trigger the short circuit detection. And 1 second, I will resolder the cables here, and then we will give it a second try. Perhaps I will fix the cable also so that there is not so much tension on it to get away. Okay, so now it's okay. Now let's go with a second try. Power, and you can see the power supply is still giving power. The Arduino is still working, and you can see 280 degrees. And now the end of this cable disconnected. So this can really be a big problem if you are working with materials like plastic or something else, and your connections are really done, or they are not soldered, they are crimped or something like this. So if you have a short circuit somewhere here or wherever, a high amp rated power supply will not detect this fault, and the whole installation will get really hot. And there is only one way to get around this. This is by adding fuses here in the 5-volt path. So you have to add a fuse here, you have to add a fuse here, you have to add a fuse here. And these fuses have to be calculated according to the number of pixels you have in your strip. So let's say you have 10 pixels. Every pixel can take 60 milliamps max on full white times 10 means you have to add a fuse of 600 milliamps. Okay, there will be no fuse for 600 milliamps, so you just take a fuse for 1 amp. And you always have to be sure to use these fuses, otherwise you have a big risk of getting the problem that I've just shown here. Because one solder drop here or a loose cable connecting somewhere because you've moved it around for your venues, can cause this big issue, and you can you have a high risk of fire. And so always add fuses to your to your power lines, and also always use big cables coming from the PSU, and then split up the cables to the fuse and then to the strip. So I hope you have learned something with this small video, and I hope I have shown a common problem that I see on this kind of installations. So I hope you enjoyed this video. Have a nice day. Cheers, Thomas.